Hello, we are here today at PCI SIG DevCon 2019 in Santa Clara, California, demonstrating PCI Express 5.0 revision 1 that just released in a PHY IP form in Synopsys booth, operating across multiple types of different channels, and also being tested across the show floor by all the different test and measurement companies who are participating this week at PCI SIG. I would like to walk you through some of these example channels, but before that, I would like to tell you, as PCI Express is being adopted by multiple applications in different market spaces, we are finding PCI Express operating across different PC board traces, PC board materials, lens, different types of connectors and cables. And that's why it's critical to look at some samples of some of these channels. So let's walk through some of the channels that we are demonstrating here today in Synopsys booth. We have two multi-channel PHY test chips communicating across these different channels. We have a PCIe Gen 5 at 32 gig, on the top going across Samtec's XMax backplane through paddle cards, PC board traces on the backplane to another paddle card communicating across to a different PHY. And then we are able to capture the internal eye on the receiver side as is displayed on the monitor here. As you see, the eye is quite wide open, even with 36 dB insertion loss across this channel. With great BER, we were able to run this PHY overnight from last night, and as you see, we were able to achieve above 10 to the minus 15 bit error rate. On the bottom shelf, we're also demonstrating a channel that is created. It's an ISI board that is built by Synopsys. Again, this board has about different traces, and what we are demonstrating right now across multiple channels, we are running 36 dB insertion loss just across the PC board material, ISI board, going from one PHY card to another PHY card. And our third channel here is across the Amphenol's Chem 5.0 Chem connector, again representing a different connectors, cables, and PC board material. Now let's walk into Samtec's booth, where we have our PHY operating across a different channel for some of the new technologies that are being adopting PCI Express. Here we are with Ralph Page from Samtec, who's going to walk us through this demo and what we are showing here today.
Okay. Hello, my name is Ralph Page. I'm a systems engineer with Samtec, and we have a very cool demonstration we're going to show you right now. For this particular show, we built a brand new artificial intelligence box. Of course, it lacks a little in intelligence because there's no silicon on the board, but it makes up for in intelligence. It makes up for that in performance. We're using Synopsys PCIe Gen 5 to generate some signals, and in this box we have both a rigid backplane and actually a wired or cabled front plane. Okay, of course, whether it's back or front is entirely down to perspective. The channel we're showing today is actually a front plane or front cable. We're going from our accelerate cable to accelerate cable through about 12 inches of our high performance twin-ax cable, delivering zero errors. Ran zero errors all day yesterday with excellent eye results. On the back plane we have our HSE 6 connector, and even with good quality materials on the back plane, we're looking about 20 plus dBs of loss between these cards, spaced about 12 inches apart. Contrast that to only about 2 or 3 dBs if we go through with a cable. Each of these cables is 16 channels or 8 lanes, so you can see we've got a fully populated and assembled system here with just terrific performance.
And I guess the application is artificial intelligence,
machine
learning.
Yeah,
So this is a new environment.
Yeah, you could just imagine taking these cards right here, throwing some AI chips on there, some GPUs or whatever would be fantastic.
Thank you. Thank you, Ralph.
Already done.
This
Well,
is
thank
great.
you.
I hope you enjoyed that. Now, with PCI Express 5.0 at 32 gigatransfer per second, it makes it very quite difficult or quite challenging for designers to implement this PHY in their design. As a result, it's very critical for the PHY have a very accurate model. With that, let's move to Keysight's booth, where we have collaborated in correlating the IBCMI model for this PHY with silicon results. Here I am with Pega Alavi, who is going to walk us through the IBCMI model correlation for us.
So let's start by talking about some results that we have from the Synopsys hardware board. What you're looking at over here is the internal eye at the receiver output. And you can see that we have simulated this using Keysight's ADS, and we're getting close correlation between the two eyes. So you can see this matches the hardware's eye, the contour, and also you can clearly see that we passed the PCIe mask at this eye and also better put together at this other eye. So we're getting very, very good correlation results. What we also did using Keysight ADS was we simulated the transmitter for transmitter tests, and this is one eye that we got. You can look at the eye shape in addition to the contours and also the BER count, bathtub curves. And what we also did was then we put this together to take a look, and what we saw is that we see close correlation between simulated results and also measurement. What you're seeing is a screenshot of the test bench that utilizes Keysight's lab equipment scope as well as Synopsys' PHY. So with this, what we can actually see is that both in transmitter and in the receiver test, we're seeing close correlation between simulation and measurement.
So with that, we had a journey walking through different types of channels that PCIe Gen 5 is operating across, some cables, connectors, backplanes. And of course, if you were at the show, you would have seen all the different test and measurement equipments that are using our PCIe Gen 5 PHY IP in their test and measurement. With that, I hope you enjoyed the video. Thank you.